Just a moment. Yes, now it started.
Okay.
So, dear audience, in the name of Faculty of Architecture and Design, I want to welcome all to our third ArchiDesign Timber Talk. Our faculty member Demet Sürücü, you already know her, so we'll be moderating the talk. Our guest professor is Tina Wik, well known with her work about sustainability, her conservation projects, but also new constructions using wood. So, dear Demet, the word is yours.
Thank you, Elif. Good evening, dear students, faculty members, and our guest, Professor Tina Wik. We are very delightful. Tina is our speaker tonight, and Tina will share her knowledge and great experience on building with wood and conservation and restoration with wood. So I would think we will learn about wood as a construction material with examples on contemporary ones tonight, this evening. So now I would like to give some information about Tina. Tina Wik has worked on both new construction and conservation projects in Sweden and around the world, different countries. New projects have often been in wood. Maybe I can give some information about the projects. One of them is Vistaberg, is a larger small-scale housing area with more than 100 units, while Voluden is a multi-story housing area with buildings up to 5 stories with wooden structure. The aim has, in many projects, been to develop wooden construction, which has resulted in the office often working with experimental projects. Voluden was an experimental project with a multi-story wooden structure in Malmö. Was built with a combination of thin steel frame with a solid wood structure. Another project is Norra Parish House. The intermediate floor was built of solid wood. The first such as used in Sweden. I know the project has an award, European Astra Award, being a good example of modern addition in historical areas. And Tina has long experience in post-disaster architectural conservation gained during her work in Bosnia-Herzegovina following the 1992-1995 war, where she was project leader and responsible architect for the NGO Cultural Heritage Without Borders between 2000 and 2007. This evening, Tina will talk about sustainability in solid wood trends and ambitions in Sweden. She is also professor at Dalarna University. She is also member of ICOMOS and general secretary of ICOMOS Wood Committee. I think that's all. Word is yours, Tina.
Thank you very much. Thank you. I will show some of the projects you mentioned, and I just put them in the context of the Swedish. Let's see here. Can you see my screen in the Swedish context? Can you see the screen?
We cannot see, but it takes time sometimes. We are waiting.
Let's see now.
Now it's coming, yes.
Yes, it's coming now.
Now I can see sustainability in solid wood.
Yes. And I actually called it now. I'm sorry, you will not be seeing me anymore because now my screen is covering the whole presentation, the whole screen. But I'm calling it the trends and ambitions in Sweden, because it's really it's a situation in Sweden is like this, that we are really in a transition period. The focus is very, very much at the moment on sustainability. And wood is considered to be the most sustainable material, and we have big discussions at the moment about to stop using concrete, or not stop using, but to lower the level of using concrete, using concrete a lot. And our authorities are even trying to block production of concrete or cement in Sweden, which would mean that we would have to import all the cement we will use for concrete, which would make using concrete much more expensive. So now the material wood is becoming in focus in a much stronger sense than before. And I will give, let's see now how I will give a small background to what happened. And using wood in large-scale buildings started after 1994 in Sweden, when Sweden signed a EEC contract or agreement where that changed our building code so that we have had a functional building code and not a more prohibiting. So before wood in larger buildings than 2 stories was forbidden, but after this agreement, we had any building had to secure a certain time for fire protection, regardless material, which meant that we could start using wood in larger scale buildings as long as we could guarantee the fire safety. But with fire safety, we found there were other technical problems as well that had not been developed in large-scale wooden buildings, since that had not been built for more than 100 years. And that was humidity, how to solve the humidity problems when building with wood, how to solve the sound, acoustic between 2 different apartments, because we had requirements that are based on performance of concrete, and now we have to use the same requirements on wood, and the wood is actually has some kind of other properties than concrete. So it was not so easy to just transform these solutions to wood. And also, as you all know, wood is a living material; it moves, and all this had to be accounted on as well, especially building very high buildings. So these were new problems facing the new building system that builders and developers were not able to handle, and this gave a big insecurity and also meant that they were reluctant in choosing wood as a building material for the structure. And anyway, there were companies who started this, especially Skanska, which is the biggest entrepreneur building company in all Europe, and they were promoting using the usage of wood, because also perhaps they were not really, the bosses were not so technically aware of the problems that they were facing, but they saw that from the American examples, building in wood was much cheaper than building in concrete. So they really promoted these first wooden multi-story buildings. And but due to these technical problems, we also got economical problems, and we had new aesthetical demands, and new building methods had to be found. So this put quite a big demands on the new buildings system. And as I told you in the beginning, we had mostly economical incitements why to build in wood, and eventually sustainability took over these kind of discussions when we found out that the financial difference between concrete and wood was not as big as they had thought. But and we can also see that now that we have to build with airtight solutions, so to get a low energy consumption, we have to find ventilation systems to secure the humidity problems, new materials. We should also try to see how can we combine wood with other materials, and also can take in even new materials into usage, since we if they prove to be sustainable. And we have at the moment we have 4 large, no, here's 5 actually, large-scale actors in Sweden. Derome, Muell, Martinson, Lindbeck, and Stora Enso. And I will show you examples from most of these not from 3 of these actors in the presentation here. And the first building with multi-story, using multi-story wood in the multi-story house was Velludden, as Demet told you. And first we counted on 4 buildings with 4 stories, and then like here, and then the builder Skanska, who was promoting a usage of an American model using studs, joists, wooden joist in this system. And but to get some better economy, he suggested that one of the buildings should be built in 5 stories, which was actually quite an interesting decision, because then all of a sudden the fire demands changed from 60 minutes of fire protection to 90 minutes fire protection, which gave us a very, very good possibility to study how this would affect the costs and the building process, and also the construction itself. And this was being the first multi-story house, modern multi-story house in wood. And we also started. I was looking for how could we make this building kind of have a wooden character, in spite of being forced to be plastered, or where the wooden structure was hidden due to both insulation reasons, and fire reasons. But we could use a wooden facade in parts that was in one fire cell. And this is also the first modern structure, or the first building in Sweden where we use the lift shaft we build it in wood. And this has become quite common after this, because that is because of cost reasons, because it proved to be much cheaper than building a concrete lift shaft. And you know that when you load the wood in the fiber, directional fibers, you hardly get any movements at all. So that's what we were doing when we were building the lift shaft. So it was really working very, very well. But as being the first project of such kind in Sweden, we saw that the biggest technical problem was the intermediate floors. It had to be, of course, fire protected, because it was different units, families living on each side, up and down. But we have also building codes saying that we have to have a certain acoustic insulation. And this now I don't know what happened with the sound. Somebody put on and this meant that made the dimension of the intermediate floor grow very much. And that it was also one of the things here why I made these big frames around the windows, to kind of hide the huge measurement of between the floors. But we tried 3 different systems for in the intermediate floors, and this is one. This is the one the contractor actually wanted, because here you can install all the installations without pre-planning, but it meant that we had a very, very huge dimension, almost half a meter thick intermediate floor. So we experimented a new one where we put joist, like a semi-solid system, where you could put at least the electrical installations in between the joists, and in this way we got the intermediate floor down to 300 millimeters in height. And we were measuring all these acoustic performances in these different intermediate floors, and could see that they were quite similar. And even if we found a difference in measurements, we realized that people could not experience the differences. People experienced sound from quite often from psychological reasons, not reasons that we could understand through measuring these acoustics and the sound performances. And then the next project, a few years later, or almost, was the Nora Parish House, as Demet was telling you about. And here we used solid wood intermediate floor, and here it was easier. It's one fire cell because it's an open relation between the first and second floor, and why we did this? This parish house was built in a historic town, one of the 3 remaining wooden historic towns in Sweden, and all the houses are of wood. So it was very natural to propose this building to be built in wood. But we had a modern plan where the loads were not going straight down from up and down because we had the walls in different placements on the 2 stories, which meant that we needed an intermediate floor that could perform like a concrete floor, where the loads could be taken up in askew from each other, from the 2 floors. So, and this was what this solid wood intermediate floor can do. So you don't have to have the loads like in a column and beam system above each other. You can push them aside. And another advantage of this of using this floor was that we could open the shafts. We could just saw them up in situ, and we could also. This is not the final line of the second or the entresol floor. We could saw it also in situ and saw all the different forms, because it's a little bit like an omega form, the whole line here, and that could be done also in situ, which made it much easier for the builder to do than instead of having to think about that in advance. But otherwise, you see, it's a traditional or not from the 20th century traditional way of building with joists and insulation in between on the outer walls. And let me see what happened here. And here it is this, and you see this is the upper floor, and here's the lower floor, and so this is just I'm just showing a few pictures of this building, and here, yes, it goes. And here you see the parish house, and you see the form of the plan and the church, and you see also the line, how this wooden town, it's a 17th century wooden town with a really Renaissance plan with strict square plan. And here you have the plans and the pictures. My computer is so sensitive, so it kind of jumps further when I just touch it. But then from this project on, I'm showing quite a few of my own projects, but I will not show only my own project. You will see other projects as well later on. So here's the next project was one of the first solid wood villas in Sweden. And this was also before these German or Austrian or Swiss CLT boards were imported to Sweden. So this was a system that was invented by Thomas Alsmarker, who is a structural engineer, and he made solid wooden system that he wanted me to use in his own villa. And all these panels were produced in a small wooden factory in Sweden, not so far from his house, from this site. And this is a town in the southern part of Sweden. And he said he wanted the house to be have no connection with the neighbors because they were ugly factory houses. And he wanted it to be open up towards the courtyard, which also faced south. So this is facing north, and here you have the entrance. And I will show you now pictures about how it looks when it's finished, and also during the building process. So here you have the structure itself. It's a solid CLT, homemade CLT panels, and he could choose in what direction he would place them. And due to this placing them either standing like this or horizontal, he could also take up different corners with different types of load-bearing systems. So if you see, look at this one here, you have hardly any loads coming down. So here the panels are being horizontal. So they can. So this part has doesn't need to carry any load at all, because this is a self-bearing part of the house. And also here is how we could build that up to 2 stories in one sequence, and then hang in the intermediate floor, which also is a better form for load-bearing courses, because this means that this part of the wall will not settle; it will stand up without any movements, because the load-bearing structure will not be loaded against the fiber direction. So, and this is the parents' house. You see this window here is this one here, and it looks to a small nice meadow, and under is the kitchen where the wife is standing. And then quite after this came the next, and this is still also an experimental part where this was a building housing fair in Malmö, the most southern town in Sweden. And here so this whole block was supposed to be built in 1 year. So it means that all the sites were being built at the same time, and this the ground here is really muddy, and so all these houses had to be standing on poles. So there wasn't enough companies in Sweden to be able to provide for poles for each of these houses, so that they had to be done in a sequence. So the logistics was really tough. And then the whole area was supposed to be open in a certain date, because that was when the fair was opening. So it was a hazard to work with this, and this is also why we chose a hybrid system, where we used, as also Demet explained, a solid wood combined with a thin steel frame. And we have these houses here. This is the block that I was designing, and these other ones are not wooden houses. So this is the only one with solid wood in this housing fair. And it was really restricted how big area you could have on this floor, and this was also, you have to have an opening somewhere on the bottom floor. So the whole detailed plan for each block was extremely tight and controlled by the city, the planning architect of this fair. And so what we did was having these everything in these houses are done with solid wood, even the non-bearing walls within the apartments. And as to get it up really quickly, we put this thin steel frame and then locked them with this solid wooden elements in between. And we tried different types of solid wood elements that was also produced in Sweden without, and it is completely before there were any factories producing these things. So they were like built for this project. And my client here, he's a doctor, and medical doctor, and he owns a lot of forest in the north of Sweden. So he wanted to use his forest for this project. So he cut his forest and reproduced the panels from that wood. And he had noticed in his career that living in wooden houses causes less allergies and better health conditions and so on. So he was really concerned of using wood in the house. And the fire, since we have sprinkler system, as you see here, we could cover this with only 6 millimeter gypsum boards, and we didn't have to have the normal thick gypsum. And here you see how it was kind of always locked with these solid wooden panels. And here we have just drawings of the of the house, and also having a floating floor, so we got no connection between the upper and underfloor to prevent sound from being disturbing the neighbor underneath. And there was also green factor, so we had to provide a green on some of the roofs, and the plan was also to have a greenery on the whole facade here. But as you see here, I want just to show this picture, because here we used also a wooden floor in this porch, and traditionally our pavements and streets in some areas in the cities had this kind of a floor, and especially of course in workshops and so on. This is wood. This is oak wood, where you can see the lines of the tree up. It's like standing up. So when you walk on it, you walk in the fiber. So you step it on fiber direction, and this and it's about 10 centimeters thick, and it works perfect in this setting. And you can drive on it, and the horses were able to also before the time of automobiles, this was perfect to have this kind of a courtyard surface, because you wouldn't get this horrible harsh sound from the horse shoes. So this was really, and here we can see that when you walk in, even everything here is plastered. It's completely quiet. You don't hear anything. So this wooden floor is fantastic in areas like this. After this period, when in the beginning of year 2000, we had a big recession, and very little was built actually in a few years. And the start of building multi-story houses with wood almost stopped for some period. And then people were quite worried how this industry, the wooden industry that was just about to start, how it would be able to develop, and some factories even actually closed down. But then came a new actor on the market called Martinson's Bygg, and they are up in the north of Sweden, where there's a lot of wood. And they are producing their it's a solid CLT systems combined with what do you call it, laminated wooden beams. And that was why they did this combination. And we were discussing that quite a lot. How, normally you use beams or you use a CLT board, but they use a combination, and that was because they could get longer spans. And this became then the highest wooden building in Sweden. It was about 2006, 8. I don't remember really. I should have put the year here. But you see, it's 8 stories, and here they have also the balconies made of wood, which they later on had to cover with some kind of small on the top. I think only the first floor is concrete, and then all the other ones are of these wooden elements. And here you see that this is they could bear from from outer walls until here, until this thickness of the house, and from here they needed to have some support in interior walls. But so they could actually carry spans more than between 6 to 8 meters without getting really very, very high, which was always been the aim, to have intermediate floors that don't grow too much. And here you see the system. As I told you, they have the CLT board. They have the laminated wooden beams, and then they have a system where they hang out up on ceiling for the apartment below, that has no connection with the structure above. And you see when it comes, it has some metal strings like this, and these are cut off, because then this will land on some supports on the apartment below, and this will land on support on the apartment above. So in this way, they can guarantee that there is no connection between these two parts of the intermediate floor, which makes it gives it a very good sound insulation. And then came the discussion: how can you build these large-scale houses without in a weather like in Sweden, like you have in Istanbul too. It rains a lot, so especially certain periods, and we have all periods when it rains. It's not we can't even know that it won't rain a lot in the summer. And it's even better. And if the winter is cold, it's better with building in snow than building in the wet rain or. So then they came up with the idea of building of covering the house with this kind of a tent or shelter, and this was done in a few projects in the year like 2010. But of course, and they found out that this gave a much quicker building time and much better building conditions for the workers, and much better light, because you get electricity all over and you could see well. So, and this speeded up the production time quite a lot, and building in wood has a much shorter building time compared to building in concrete, because you don't have to have the structure standing and drying out. So, but still, there has to be a considerable size of the project for this kind of protection to be economically, sound. For building smaller buildings it's difficult to use it in smaller buildings, because it will make the project so much more expensive. And here is another building, Sandparken in Sundbyberg outside Stockholm, designed by Wik Architects, and this is also Martinson's solid CLT system, the same as in previous project. And this is another client, and this is Folkhem is the client, and they are quite brave in their architecture, and they always use top architects. Like Wik is the most famous architect in Sweden today. And this Sen-Harry, the boss of this Folkhem, he sees something and falls in love with it and doesn't care about the cost, and then he just wants to realize it. So he started with these cedar tree shingles, as you see, and you see it there on the roof as well. So he covered the whole building with these shingles. And I think this is quite brave, especially considering that this is like 1, 2, 3, 4, 5, 6, 7th store up. So it's not so easy to change if there would be some damage. And so this is the way the shingles look, and also the whole landscaping is very carefully done, and the windows are a bit protected inside the wall. And here you can have the windows closer to the surface because they are protected by the balconies. And he also, and you see all the balconies are completely of wood, and they're hanging. It's a hanging structure. So you have an invisible beam here, as in which they are hanging. And also the stairs in the staircase. So it's a common staircase. We had the same kind of floor as I told you from my project in Malmö. And the benefit from using this kind of a stair in a common staircase like this, when you have people walking up and down, is you get hardly any sound. You don't have any problems with sound from people walking in the stairs into the apartments, because it's so quiet. And here's just one picture from inside. So you don't really see here that it's a wooden house, but it is. But all our floors are, of course, in wood in Sweden. And now I'm coming to another project, and this is my own project in Lindesberg, which is another small historical wooden town, not so far from Nora. And this is what I think is nice with this project, is that it is this is a project for the public. It's public housing, social housing. So it's their municipal housing company who decided to build a wooden house. And I had actually first designed a house with a cheaper building system, wooden building system with more volumes built in with joists. But they decided to build it in solid wood with this kind of with this more expensive wooden system. And so they had, and their ambitions and their reasons to do so was that they wanted to build sustainable housing, and they had made a decision within the board that from now on they will have a certain sustainability index that every project has to fulfill. So here you see, and here you see so here Martinsons came and they just built up the structure of the solid wood structure, and then all the different the extra parts like insulation and the facade and so on was built in situ. And so this is not the structure itself, it's only for the scaffolding. And here is how it looks like when it's ready. So it was an extension to an existing school, and we also built all this landscaping around it to provide the citizens of the town to place to swim in the lake, and also have a nice place along the lake for a promenade. And there's also risk for water coming, what you call getting up. So we have no apartments in the lower floor. All this is just technical floors or some storage floors, and then we have space for cars and so on. So the apartments are on the three upper floors. And and these are just some pictures, and they're quite simple apartments, but then the balconies are a bit more irregular to give the house a more interesting form. And here we have the courtyard, but that's oncoming. It's just newly planted, so it will be much greener from next year. And you can see the church tower behind there. And then we have the green color of the existing house that is then in some way also picked up in the staircase, which is not heated. And here we also have the same floor. You see this cube floor that we use to make it to prevent problems with the sound from the staircase into the apartments. And I'm just showing one picture of another project in Sweden. This is an interesting example because it really uses the technical possibilities of CLT boards. Here, this is a horseback riding hall, manege. I don't know if you have the same word in English or in Turkish. But this is a house that is not heated, and doesn't need any insulation. So one can really have the thin roof construction here. And as you see, it's done with IEX, with architects, and it was actually Thomas Alsmark for whom I built this villa, who is the structural engineer here. And he has these fingers. You see, here. Let me see here. They carry these boards, and then they are combined with these in a way so the upper boards will not fall down. So it's quite an intricate system. So we call it an under suspended structure. So it's a very elegant structure, and for this, and you can have this huge span due to this. And so it's only like steel wires carrying the whole roof, and also providing this system can also allow for light on the top. Then after quite recently, we have one of our traditionally biggest wooden companies called Muell. It's been sold. It's sometimes owned by Norwegians, sometimes by Swedes, and sometimes by Finns. But at the moment, it's back in the Norwegian ownership. But they were the ones that actually started making cross-laminated or not laminated timber beams in the beginning of the 20th century. So they were about one of the first producers of these kind of large-scale wooden structures in the Nordic countries. But they were quite they have not taken up the cross-laminated timber production at all, but they have developed a system with a column and beam system for very large scale or large span buildings. Not so much for private housing, but more for public housing. And they call it trä-8 system. Trä means in wood in Swedish. And now I'm showing you a gymnasium, a school in Järfälla outside Stockholm, north of Stockholm city. And you see these wooden beams here or columns, and you see the beams here. So it's really a really large scale wooden house. And here you see during the construction. And this system is really, I mean, they also produced huge laminated beams for Gardermoen airport in Oslo. And they have done the structural systems for lots of sports halls. So they are really prominent, really skillful in providing these different types of beams. And now this is combined with CLT elements for the walls. So this is just a production photo, and here you see when it's this gymnastic hall when it's ready, and it's quite nice because here the students can even climb here, and they have lots of different activities. So it's quite a modern concept of what you will do during your sport class, and also gives you opportunities of making the staircase and some of the spaces more irregular, because building in an irregular manner in a more sculptural way in wood is much cheaper than if you would do it in concrete, where you have to build forms for all these oddities. And here we can also provide they have been able to, since they have a sprinkler system, to have wooden facades in the corridors, which means that also here you get a lower problem with acoustics. And these are, of course, acoustic boards. And this is another school, but this is not this is a university level. This is a building for landscape architects in Uppsala, and this is also built with the same wood beam system you see here. And here we have some cracks, but it doesn't really matter. It works anyhow. So these are these are really solid wooden systems. And here you have this wooden staircase that really dominates the whole big hall. That is the entrance hall to this university department. And under the staircases you have this acoustic. You can make the acoustic levels of protection. So we have acoustic sheets or behind these boards, so they are invisible, which makes them much nicer. And here we have the same Muell module wooden column and beam system in a residential house, which is quite rare. but this is also it works quite well with all these irregularities to choose this structural system. And here as well, and here you have nature houses. We have these kind of buildings in Sweden in almost all different parts of the country, where you can go in and have an exhibition about the local landscape or flora and fauna. And these buildings tend to be quite nice, have a nice architecture. They don't have to follow any specific form, and can be quite sculptural and interesting. We have also books, publications, you know, with these different nature buildings that you can buy. But and this one is you know, with straw roofing and wood. So it's really, so the whole cover is not, this is not wood, this is straw that you have for traditional houses, in the roof of traditional houses, but the structure is wood. Then we have a project in Växjö, same place where I made this the first 5-story wooden buildings. That was this contractor planned a concrete building, but for some reason he then changed his mind. I think it was due to actually timing, that it was quicker to build in wood than in concrete. So then he changed his typology from concrete to wood, and he got so fond of building with wood, and that he started also developing his own idea of how to build with these CLT boards. The first ones he bought from Austria, from, I think it was Stora Enso in Austria, and then he now he produces, no, he bought them from Muell, but now he buys them from Stora Enso, a new factory in Sweden. And you see here, these are the production line, and then he has, and his idea was that on top of the CLT boards in the intermediate floor, he puts quite a thick layer of sand mud for acoustic insulation. And he has now tested it in the first project, and now he found out it works very well. So he has kind of developed his own system how he will build his houses in this area of Sweden. He's a local contractor there. He works only in this. He's called a GBJ, that means builder. And this intermediate floor that he developed is 420 millimeters high. And here you can see how he then this is this sand and mud filling, and then there will be a new layer, new floor on top of this. And I just see what are we doing in Sweden today. And so these, I'll now show you some examples of it. Started very I mean, with trial and error, cautiously, and then we have been getting more and more knowledge, and more and more actors, more and more interest. And it started I mean, the focus of wood was firstly an economic focus, where, you know, builders thought they could build cheaper with wood, and I still think it's true, but you have to have experience and knowledge to be able to build cheaper with wood compared to concrete, and this knowledge and experience takes time to get. And and because knowledge means that we have to be able to solve new problems caused by this material that's not shown in concrete buildings, but will just appear in when we have wooden solutions. Because with acoustics, we have in measuring the acoustics between the noise of the steps in the intermediate floor, the concrete, it takes care of insulates the lower Hertz spectra, while the wooden constructions takes care of the higher Hertz spectra. But it is actually what we hear. And when we were trying the Austrian solutions in Sweden, we realized that why we couldn't use the Austrian solutions was that in Austria they have a building code that measures only to the level of 100 hertz, while we measure until 50 hertz, which gives quite much higher requirements of how to solve the acoustics problem in the intermediate floors in Sweden compared to Austria. But anyway, so these and all these technical, problems like acoustics, movements, fire protection, load bearing capacity has to be handled, and people and builders have to have knowledge of how to do it, and not only producers and to how to solve them in their system, but also when you come to the actual building site and erect the panels and the parts, you have to erect them in a way so that you don't get these small gaps in between, so that that even if the element itself has a high performance of acoustic protection or fire protection, but if you have a gap, then that will be lost if you don't mount the elements in a correct way. And so it's so all these technical requirements are, you have to follow them up from the factory until the building erection on the building site. So everyone in the process has to be able to handle this knowledge and be very, very careful. And then also we're trying to get more and more thinner intermediate floors because it takes quite much space. And also we have, with all the old city plans, we have the height limit on new houses, and if you have a too high intermediate floor, you might not be able to build the last floor. So this has also been a discussion here in Sweden. How can we adapt our detailed plans to the new requirements of building with wood that would perhaps need a higher houses for the same amount of floors compared to concrete houses. And then we have facade systems. That's also a discussion. I mean, how to build these facades, because building small houses in wood, I mean, we just buy the boards and we build it. It's from scratch. But when you start building huge houses, you have to have perhaps another system so you can build the facades much quicker. And then also trying to find new building systems and hybrid systems, so where you can use different types of materials, where you can take the benefit from each material on the best location. And then we are also discussing how the building process, how much of an element should be built in the factory, how much inside, should it be, what should be done in situ, and so on. And the whole logistics concerned with the building process, as well as the business strategies. And this is also something that our contractors are perhaps not so good at, the business strategies, and they still want to get a high gain. But if you have a better building strategy, I think everybody would gain from that, because then the cost of the building cost would be reduced. And we have, of course, digital solutions, and we have new digital ways of planning and drawing with parametric design and so on. It gives a completely new possibilities of building with wood that we in Sweden are still quite bad at. So I think this will be a huge change in the future, and could also change the architecture of wooden buildings, because now we have digital systems that can send the information directly to the source. We don't even have to, and they can be produced in lots of different forms, and so we will see quite different wooden buildings in the future, or we can see. And I just see now, we see that in 2017, we had about 13% of our residentials in the multi-story houses were built in wood, and today it's about 17%. So it's really the building with wood is increasing, and I think quite soon the proportion, the percentage of built multi-story houses in wood will be 20%. But almost all small-scale houses in Sweden are built with wood. You wouldn't find a concrete house, a single-family house or row house. That's too expensive. And there are more and more different producers appearing in the market, and this will probably make a change concerning price. And I think small builders are now moving towards building large-scale buildings with wood. And then we have also, there's a huge research going on concerning wooden buildings and performances in different situations, and especially now how to meet the demands on zero CO2 levels in building. This is a really one of the most things that are most in focus in Sweden. And we have wooden buildings all over Sweden, so it's not like just concentrated into one part. You find them all over. And we have 50, I think about 50 municipalities in Sweden, and about almost half of them have a wooden strategy at the moment. So everybody is concerned with building in wood. And the projects you find are any kind. You have schools, we have any level. You have kindergartens, gymnasiums, universities. You have all sports halls, housing, different types of housing. So there are museums. So we have all types of projects are built in wood. And this means that also we have now looking at this architecture, wooden architecture starts becoming a specific issue. And here we have one sustainable experimental project was this Vallastaden, which means the Valla city, outside a suburb of Linköping, southern town in south of Sweden. And they really had the municipality. They provided this area with a completely new water and sewage system. Because the one we have in Sweden everywhere is quite wasting a lot of water, and we have a lot of water, so it's not been a big concern. But now this is being looked at, and so eventually the water and sewage system will be changed. And then they also wanted to get away from the large scale builders. So all the builders got quite a small plot here, and then they had to choose different architects to make this area more interesting. So this is also something that could be interesting to look at, because this has an ecological approach and a social approach that is really quite new in Sweden. And it's really from the municipal level down. And now I'm going to kind of end here with the new thing, quite a new thing in Sweden, and it started in the beginning of 2001-2 with this project I was participating in. It's a small research project at the University of Dalarna, together with engineer Henrik Janols. And we did this. The idea was to show that building with solid wood could be done in a modern way. Didn't mean and the idea was to reach a passive house standard. And we wanted to show that it didn't require small ugly windows, that we could build a modern house that would still meet the demands of passive housing and have these large windows with sliding doors. And we also, and this is, so it's in Stora Enso's solid wood system, and we made, I designed different ways of assembling them. And I also talked to the producer of this sliding door system. We made 3 small dubs here, so that you could, so it's really airtight. And the whole how they are linked into the integrated in the wall is also makes us very airtight. And we also tested different insulation materials. And after now many years, so we have had more than 10 years of testing, we can see that the wooden insulation performs much better than mineral wool. And we can see that the curves are much less smoother, that you have easier humidity transmission, heat transmission, and through wood insulation compared to mineral wool or stone wool insulation. And what we did is that we really put, so that we always had this what we call S curve, so that we could get them really guarantee that all connections were completely airtight. And what we did also, we then decided, well, you don't need to have a concrete foundation. So this is gravel and sand, and this is insulation boards, and this is the wooden board. So we did this like this completely from. So there's no plastic and no concrete in this building. And after 4 years in one location, we moved the whole building to another location. And we could, and then because what we did, initially we didn't think about the foundation as a research project, only the different materials in the insulation, as well as this building without any plastics. So we measured airtightness and found that it's completely airtight. We found out that the wooden insulation performs better than the mineral wool. But then when we moved the house, we realized that there was no humidity under this board. It was completely dry. So this became, so now we put sensors under the foundation and found out that this works. We don't need, for smaller, up to 2 at least story buildings, you don't need a concrete foundation. You can build without it. And here also put this, I made this just this hand drawings for the different solutions, and some of them were transformed into digital. So what I did is that we tried then to make people in Dalarna interested in full-scale tests. But they were not. I didn't get anybody who dared to test this method of non-concrete foundations. So I decided when I built my own house to do it, to test this way of building. And so it's exactly, one could say, a full-scale project out of this research project. And this is the location. It's by the sea, not so far from Uppsala, 100 kilometers north of Stockholm. And it's so this sea, it overlooks the sea, but it's in the border of the forest and on quite a rocky piece of land. So this is so the whole this is the site plan. And so I decided to build exactly in the same way. And so here we have the basement with the sauna, of course, and shower, sleeping room, and then an upstairs with 2 guest rooms. And this is facing south, so the whole roof is sloping up, so we can put solar cells on the roof, and also having quite an open plan, so that the hot air would be distributed around the whole house. And this is also quite a way of ventilation with a sensor-steered evacuation, air evacuation. And then we have in the basement we have some fresh air coming up here, and it comes from a long pipe underground and up here, and it's distributed all around this area, and then it comes up here and is distributed also in the upper floor. And no, the wrong direction. And here you see it. We have solar cells, and this the entrance door is protected by the staircase, and actually the staircase is reused from one of my projects from another part of Sweden. And and here it is. Here's the foundation being done. So here you see it with the gravel that is really, and then it has to be very smooth. And we had some support, some connections to the rock in 4 corners, so to prevent from the house from being lifted up. And here you see the all the installations that had to be prepared in advance. And these are the insulation boards on top of the gravel. And we had to have a cover from radon, the gas from that. That's a rule in Sweden. But anyway, so this was done, and as when the foundation had reached this point, then we just waited for the house to come, and the house came on the 7th of January. One morning we had a big crane here, and then the board. This is without just the insulation, and then the boards start being located on the different places, and then they are screwed together like this. And then the different parts are being mounted like this. And now we are 11 o'clock, 12 o'clock, and so on. So it's and then it starts getting dark very early this time of the year. And then we were really racing against the time. And then at 10 o'clock we realized that it would start snowing in a few hours. So we just continued quickly. And at 2 o'clock at night we had some small water in, but anyway the house was closed. So from 7 o'clock in the morning till 2 the next night it was sealed, and all the windows were put in the factory and insulation on outside, except for the big windows in the big room. And here's the staircase, the stairs that was reused from another project. And here you have the big the room when after it was sealed the next week, the rest of the windows came. And here we just have also the corner is just the glass. And and then eventually it starts getting more and more ready. So this was done, and only the facades, the wooden panel, the boarding was done in situ. Everything else was done in the factory, and also the covering of the roof was done in situ. So here it is at the moment, and it's not completely 100% ready yet, but it's on the way almost. And here we have the ventilation system, which is sensor driven. So these are steered. So it's really a low energy ventilation system where this uses less energy than an FTX system where you have energy saving systems implemented in the system, because the sensors are drives this ventilation so that it only works when it's too warm, too high humidity, or from the toilets too bad smell. So it's really, and I have it behind this curtain. And then here we have the fresh air comes in the pipe from here like this and enters the house. And just some pictures from when it's done. And here the sea and the sauna, of course. And you can have also the shower rooms where this is actually the structural part. So we have the structure visible everywhere, and this is also the intermediate floor, the wooden, but just painted. So it's really a simple way, and the doors are just in the same material, thinner doors made in situ. And so what has happened now is that this has caused some kind of interest in Sweden, and I see there are more and more people interested in building without concrete. So this is a new trend, and we have a new rules coming that we need to have almost passive house standard, at least, so almost zero CO2 houses, and which saying that we have the difference between a zero CO2 house and a passive house is that with a zero CO2 house, you must also choose your materials in a way that will not, that in a sustainable way. So this means that you cannot, you have to be careful with how much concrete you use. You have to be careful in how much steel you use. So also these windows are completely wooden windows. The insulation is completely wooden insulation. Everything is wood here. And this has made an impact or interest, caused an interest in this Fiskarheden Villan, which are one of the biggest producers of single house units in Sweden. So, and Struktura had communication with the structures engineers and also Fiskarheden Villan, how to build this type of a foundation. And and Mondo was the architect for this project. And so now they are building this test project as for the first time, and to be later on implemented as one of their houses in their production line. And you see it's quite a simple house with two bedrooms and one more. And this you can also, if you want, you can rent this part out, and then you have all the water units in this area. And here are the pictures, from the renderings from this project, the interior, and you have and the facades, and now it looks like this at the moment. So here you enter, you have the house, this part of the roof or attic. We have all the technical equipment, and under this one is the water units, and then that's on the far away you have the unit you can rent out. But interesting, and here you have the system, and here you see this is very similar how they did with a foundation without any kind of a concrete. And then this they will also have a part of it with towards sun with covered with solar cells, and then they cover the rest of the roof as well as the whole facade with organo wood. This is the wood, just fir, and then they have a silicate treatment of the same as I have on my terrace, and they have the whole both roof and walls with this kind of wooden protection, and all parts here are of sustainably chosen material. So you don't have any kind of foreign materials or non-sustainable materials. Also, the insulation on the windows are made by textile, and this is wooden. This is thermotree. This is wooden insulation. Here's wooden insulation. So everything is and this is gravel, and this is also the same kind of insulation boards as I had. It's recycled. This is plastic actually, but it's recycled. So this has, of course, requires some heat to be reformed. But then as soon as they have something that will cause some CO2 imprints, they have something else that will kind of replace it. And then they also have a social sustainable idea here, so that all builders are, you see, women. So the whole house is built by women. And so this is it's also a way for them not only to build a sustainable house, but also to have a sustainable system where you can implement a better equality into the building sector. So thank you. This is I can have 50 minutes more over time.
Thank you very much.
It
was a marvelous presentation.
Thank you very much, Tina.
Now I can take it. So now, can you see me now?
No, I can still see your screen. If you can stop sharing screen, then
I'm trying to say stop. I have to say stop. Can you see me now?
Yes.
Yes.
Yes. Okay, dear students, dear participants, do you have questions? Maybe I can start. During the students are thinking about the questions. This is not a question, but something what I really like during your presentation. The first thing, you showed very different kinds of buildings and very different kind of construction possibilities. And then at the beginning you mentioned with wood it's cheaper. And I thought, okay, in Turkey with wood cheaper, this is not possible, you know, and I am for wood. But then you mentioned somewhere the knowledge makes it cheaper. So this is really, yes, how can we get there, we, the people from Turkey, that we can increase our knowledge that timber buildings are also cheaper in our country? I don't know, maybe just brainstorming.
Well, I think it used to be so. I think otherwise you wouldn't have had so many timber buildings before, historically.
Yes.
And that was also when people knew how to build with timber buildings. So I think to regain the knowledge of how to build with timber would make a difference. And I think when now, I mean, it's always a problem with builders to change traditions or change what they are used to doing. And in Sweden also, it's really difficult to make builders stop using thinking that concrete will solve everything. That's still, I mean, still we have the main part of our multi-story buildings built in concrete. But I think this will change more and more and more. And I mean, it's not that they should stop it. It's not at all. This is not the idea. But it has to be reduced because we can't, it's unsustainable to build so much with concrete. We cannot do that due to to our climate. Climate reasons will I mean, force us to start building in different ways. And then you have to get the knowledge, and you have to get and I mean, you cannot have it immediately. It's something that grows. So I mean, you have to accept that some of the project might not be economically extremely sufficient, I mean, efficient in the beginning, but eventually they will be. When people start knowing how to build, what are the expensive parts that will have to be changed, modified, and so on, then you will reach. And I think now with the Swedish would say, now they reach the conclusion that today the knowledge is so at least so spread out that one can claim that it should be cheaper building with wood. But it takes time. It won't be the first time.
Thank you. I'm looking, dear students or dear participants, do you have questions?
No question. But I think whatever you build, you have to, I mean, you can build with clay, you can build, I mean, you have fantastic possibilities of building with clay, also different, but it's really to start thinking about what is sustainable, what is the footprint of different materials. I think that's really essential for everybody in the world. And this is I mean, so it's not that it has to be a particular material, but it has to be a sustainable material.
Then I can ask another question. I'm just curious about this insulation material you are using as foundation instead of concrete or on the top of the gravel. The material.
No, I mean, that is not the insulation is the same as if I would have had a concrete foundation. I mean, the gravel, the packed gravel, that is what is being used instead of in concrete.
Okay. The insulation is just extruded polystyrol or something like that, or something different.
Yes. It's like, yeah. So it's not, and it has to. So it's not, and it could be. I mean, silicate based, based concrete. And I had hoped, but it was too expensive for me, so I couldn't buy it. So and then it would have been even more sustainable. But that was so sometimes we have still, but I think that this material will in the future be much more common for the foundations. I mean, and it's more secure and reliant than these plastics. So it will come more and more alternatives to concrete. But that was for me a matter of finance. So I had to get a cheaper material.
Thank you.
Abdul
yes, Göksun Hocam.
Hello, thank you very much, dear Ms. Tina Wik, for this again enlightening lecture. Actually, I am here with my students of graduate studies. They are research methods students. There are around 35-40 students listening to you today. And most of them are interested in topics related with sustainability, construction, and we have students from different countries, from the Middle East mostly. So I would like to ask in their names, what do you think would be future research topics for them that could initiate maybe sustainable and maybe timber-based construction, new technologies in their home countries, including Turkey? Would you have any recommendations for these graduate students? What would be the research fields?
I think there's a lot of knowledge in traditional housing that could be implemented in a completely modern house. And if you have one of the greatest architects in the world, it was from Egypt, Hassan Fathy, and he implemented he developed even the Malkaf system, with a natural ventilation. So he used in his projects in Paris, so he could get even low, very cool air down to the basement. So I think, you can use a lot, and in Oman they have, and in Dubai they have very nicely usage of the Malkaf system also, where you don't have one single direction of the wind. So you can also, it's not even, you have to see what are the conditions in your country, and I think there's always been historically very good solutions in traditional buildings, and to implement that, and perhaps you can develop it, you can strengthen it with some fans, some electricity a little bit, but I think really to think about, and in your country you have a lot of solar system ways, being able to use solar heating and solar cells and get electricity from that. and also using mud in a better way. We are also thinking about this a mud plaster, and especially mud plaster in the interiors, because it is very gives a very healthy air inside the house. So I think about and not using. There's so many strange new materials, and to avoid those and see what can we have for low cost. And I mean, it's not about, and you can put it in any kind of form. It can look, I mean, modern. It can be look. I have visited a combination with wood and mud clinic, a medical clinic in Zurich, where they wanted to use the mud plaster interiors due to that it better gives a better conditions for people with allergies. So I think it's there's so much to be done, so much to be studied from using the possibilities we have in each part.
Okay, thank you very much. So you say they should search or make research on the local wisdom of
yes, I think it's a very good starting point.
Okay, thank you very much.
Someone.
Abdul wants to ask a question.
Hello, professors. Can you hear me?
Yes, I can hear you.
Okay, thank you so much for your presentation. We really learned a lot of things. So regarding the topic, although I agree with you, and I think this is a very good way and a good solution, but I have my doubts, and the first doubt is that, okay, you showed as an example a building with a university, which was a university in a bigger scale. And I'm just having this thing. I was thinking while you were presenting how it is possible that we have this kind of solution for fire, for example, in terms of emergency incidents and stuff like that. And how could it be compatible with other buildings? These are my questions, and I would like to hear your opinion.
I mean, there are different ways of protecting from fire. I mean, concrete is not very good for fire. It cracks and it kind of falls down. And when it falls down, it's very heavy and it can kill you just by falling. I mean, any big building could do that. But and steel, and it's also fire protection. You have to, because it gets weak and bends and collapses. So you have no material that can stand fire. And you have for any amount of time, and you have wood, and how wood performs in fire is quite well known. Either you protect the wood from fire if you have too thin wood, or you over dimension wood. You know exactly how many millimeters per 10 minutes it will burn down. So I mean, so there and you have to have thick wooden constructions could sometimes be more fireproof, fire safe than concrete or a steel building. But in many cases, due to, at least in Sweden, fire protection rules that you are not allowed to have in larger buildings a material that can spread the fire. So this is why we always put gypsum boards on wood in these houses, so which gives the structure of kind of almost 60-minute protection from fire before it has burnt through this gypsum layers.
Thank you so much.
Are there any other questions? I'm just looking.
Ruba Khaled.
Hello. Thank you for this lecture. I just have one question. Isn't the sustainable building techniques more expensive than the normal one?
I think it depends on. But as normally, if you today it would be more difficult to get some of the materials, and they would for sure be more expensive than the ones you can get for cheaper in the shops for building materials. And this is very much due to they are not producing as big production lines and so on and so on. So as soon as you have something that is produced in a smaller amount, it tends to be more expensive. But then there are materials that you can more easily get yourself. But they say that to build a sustainable building would be about 10% more expensive than another building. So that's true. And it could be 15-20% more expensive. I don't know, it depends on what materials you choose. Wood is the cheapest material in Sweden. So if you have a wooden facade, it's cheaper than a plaster facade. So it depends on, of course, I think, where you are. But if you have a sustainable house, which is also doesn't have a high running cost, it's quite quickly that you have saved the money due to lower running costs.
Okay, thank you.
Then I would like to say one thing about this sustainability. There are always costs for living, building, doing whatever you do, but there's the question of who pays for these costs. If you build a house that restrains the society, your neighbors, everybody will pay for the bad air, for the this production line will cost the society. But it's not you yourself that pays, but then it's the society paying it. But there's always somebody paying for these choices that you try to avoid. I mean, if you don't take care of nature and the input, the CO2 imprint that you cause, then you have somebody else paying for it instead.
Okay, thank you.
So, Sura Mohammed.
Hi, Sophia. Thank you for the lecture. But I have a question that since we think about wood, it might be also difficult that we can call sustainable since it's deforestation. So
could you talk a bit louder? I have difficulty hearing you.
I'm sorry. I said that it might be a little hard to think of wood as a sustainable construction material since it's associated with deforestation. So do you think that the bad effect of wood is less than using concrete and the other materials?
Demet, did you hear her? Could you just...
No, I can't hear. Sura, can you speak more louder?
Sura, maybe you can write your question. It's better because this is somehow a phonetic problem that we cannot really understand you. Somehow we can hear you but not understand. Can you write your question down? Chat box?
And there's another question in the chat box.
Yes, how old is the building in this type of building, and does it need continuous renovation? No, wood does not need continuous renovation. It's just like any other building. It has sequences when it needs to be maintained. And Sura, I don't know if it was the question about some other materials than wood being sustainable as well. I don't know if that was a question or not. No,
I think she's typing. I hope.
Okay.
Yep, sir.
In the meanwhile, Demet Hanım, do you have questions or additions? No.
I can maybe I can add some words. I know most of the companies in Sweden, Muell, Stora Enso. I have their knowledge on manufacturing glulam and CLT as a construction material, and I can add some information about Turkish market. We have only one producer for glulam and CLT, and the second producer is working on the glulam manufacturing. So in my opinion, yes, we will again start with wood, but first we have to support the industry and forest management for especially for plantation forest areas, because Sweden is very different, has different forestry management, because in our country forests are the owner of the forests are the government, the Republic of Turkish Republic, but in Sweden people has their private forest, so they can use their own timber trees for their own houses. So forest management has some differences between two countries, and as I know we have a very good historical buildings examples. Some of them is standing, but I believe historical building teaches us how we use wood as a sustainable material. It gives some information to us. History learn us something about how wood is a sustainable material. We have some hidden details in our historical buildings. So our students and we need to see the first historical buildings and try to understand their techniques. Then I believe we will do and design with timber better than now. And I know it will take time, but we can build more than today in the next future.
I'm sure. I think you have many people who are quite knowledgeable, and especially craftsmen, knowledgeable craftsmen, how to build in wood, which is very, very important. But I would say in Sweden we have also big forests owned by the state. It's not only, all of them are not privately owned, but we have both state owned and private owned.
Yeah. So I would like to add the information for our students.
Yeah. Very good.
There's no question.
No, Sura gave up.
Actually, if I may, I can ask another question. I'm thinking of the Middle East and countries that do not have much, forests, more dry and having desert. So, do they need to import this material if they want to use timber? Or then will it make it sustainable? Maybe that's another issue.
I think that one should use less timber in those countries, and more. You have stone, you have brick, you have clay, and of course timber is nice to use as well, but it has more, not as much as in our countries. And I know that one of the biggest importers of Swedish wood is Egypt.
But it doesn't make it sustainable then, because
no, we have a long way to export, to travel. But it's but I mean, Turkey has had a lot of forest. It's not so you have and so you have forests closer by. But I don't know how it was traditionally but these countries, desert countries, have never had so much wood.
Okay, so it should not be fashion. I mean, it doesn't seem as a fashion, or it shouldn't be promoted as a fashionable design.
I think to think about how was wood used in the Arab countries earlier. it was used, you had all the wooden elements. You have beautiful wooden ceilings made of wood, sabras, the doors made of wood, mashabeyas, the windows made of wood. But all of them are made of small pieces. And you have lost this tradition of putting together bigger wooden elements out of small pieces. Because it's ingenious, because you could just take them apart and repair when they were some parts was broken. I mean, so I think this is to be able to make wood in a different way, what is suitable for each country, for each geographical region. Because wood is of course very good to have in windows, in doors, in floors, in ceilings.
Okay, thank you.
Sura is back, I think.
Sorry for the interruption. It seems that I had lost the connection. You hear me clearly?
Yeah, better, yes.
Yeah. I want to ask about, I think it's hard for us to think of wood as a sustainable material, since it's associated with deforestation, as you know. So do you think that even if it's associated with deforestation, that it's still a sustainable way?
You were asking about wood as a sustainable material.
Yes.
Yes, and what was your question there? If it is
That as you know, that we can get the wood from trees.
yes,
So by using so that might cause deforestation. To cut more trees, that will cause pollution and all the way
yes,
that
yes. You always have. Yes, you have to be careful with. I mean, we always replant. When you cut, you replant. There has to be a correct forestry, otherwise it's not sustainable.
Okay, thank you.
Mm. Actually, in Sweden we have a big discussion. We don't take care of our wood either in perhaps in the best way. Sometimes we think that there should be more forests that should be kept untouched, and it's not only due to sustainability in the building sector and to use for wooden material. It's also due to life. I mean, to all the plants and all the insects and all the flora and fauna that is dependent on wood and the forests. So you have to leave some of them, and you have to leave some of them just untouched. So this is a big discussion in Sweden at the moment. What we call the multi possibilities for the biological biology.
Mm-hmm. Maybe I can say something. I think 50% of the Swedish lands is covered with forests, Tina.
Yes, about
yeah. But Tina shared some numbers with us. Approximately 20% of the houses are built with wood. But in Turkey,
the multi-story houses.
Multi-story houses with
90% of all.
Yeah.
Yeah.
And I think the numbers explains how wood is sustainable. If you use wood in your life is a building material, you protect your forest and you plant new forest areas. If you don't use timber as a construction material, you forget maybe plant new forest areas. It's the management, and it's a balance between timber industry and forest management and the architectural design with wood. It's a kind of balance. If you prepare building with wood, you have to protect your forest for the next generations, I think. Yeah.
And we have a situation now when Norway has much older forests than Sweden. And the reason is that the Norwegian geography is much more difficult than the Swedish ones. Here we can just cut the wood easily, but in Norway with all these hills, it's more difficult. So they have fantastic wooden quality. You can get really good wood in Norway.
Yeah, I know. Okay. Thank you very much, Tina, for your presentation. This the detailed presentation. We have some examples and your own project, multistory houses and school buildings and other sports areas. And thank you very much for the detailed and impressive presentation. Thanks a lot.
Thank you. Thank you.
So I have just a small sentence, Professor Wik, thank you for the very informative presentation and talk. We have a little tradition in ArchiDesign talks of BAU, Faculty of Architecture and Design. We are donating in our guests' names. So a donation has been made in your name to SAVE Foundation, helping underprivileged children for equality in education. So thank you very much.
Thank you very much.
Thank
you.
Okay.
And hope to see you in Istanbul next time.
Okay, hope to see you, Tina. Bye-bye.
Yes. Bye-bye.
Good evening.
Bye.
Thank you.
Thank you, Göksun Hocam.
Thank you.
So I'm ending the meeting.
Thank you very much, Elif Hocam.